In this video, we are going to cover real analysis questions from WB Set 2022. The first question says, a polynomial satisfies these conditions. Okay, this polynomial P has zeros at -1, 0, 1, 3 and 4, these 5 points. And this polynomial does not have a zero at 2. What is the minimum degree of such polynomial? Well, since there are 5 zeros of this polynomial, so the minimum degree of such polynomial is obviously 5. It can be more than 5, but the minimum degree is at least 5. So this one is very easy. Let's go to the next question. The second one says we need to find this limit. Okay, cos whole to the power 1 over sine squared x when x tends to 0. Now let us take y is equal to this whole expression. Now take log both sides. It will become log y is equal to, since this is in the power, so it comes to the denominator, so log cos x over sine squared x. Now take limit both sides. When x tends to 0, it will become log cos x over sine squared x, which is 0 by 0 form. So now we will apply L'Hospital rule. So what is d dx of log cos x? It will become 1 by cos x into minus sin x, and d dx of sine squared x is 2 sin x cos x. So from here sin x gets cancelled, and this gives minus 1 over 2 cos squared x. So the limit of this becomes minus 1 over 2. Now to eliminate log, we will take exponential both sides. So limit y becomes e to the power minus half. So the right answer is 1 over root e, which is option 3 is correct. Option 3 is correct. Now let's go to the third question. The third question says that fx is equal to 1 over x square and gx is equal to 1 over x when x belongs to closed interval a to b. Then by Cauchy's mean value theorem, there exists C such that this equality holds. Okay, now we have to find the value of C from this equality. Now we know that f dash c is minus 2 over c cubed. Since fc was 1 over x squared, so f dash x is minus 2 over x cubed, so f dash c is minus 2 over c cubed, and similarly g dash c is minus 1 over c squared. Now put these values in the given equality. It will become f dash c over g dash c equal to fp minus fa gb minus ga. Now put these values into this equality. It will become minus 2 over c cubed and minus 1 over c squared. Okay, and here fp minus fa and gb minus ga. So simplifying this, we will get c is equal to 2 over 1 over a plus 1 over b, which implies that c is the harmonic mean of a and b. C is the harmonic mean of a and b. This is the formula of harmonic mean, isn't it? So option C is correct. That says C is harmonic mean of a and b. So option C is correct. The next question says alpha and beta are roots of the equation this ax square plus bx plus c. Then we have to find the value of this limit. Okay, since alpha and beta are roots of this equation, alpha and beta satisfies these two equalities. Which is alpha plus beta is minus b over a and alpha beta is equal to c over a. Okay, these two are basic conditions for being root of a quadratic equation. Okay, now we need to find this limit. Now see, if we put alpha right here, the denominator becomes 0, and if we put alpha right here, it will become 0. Why? Because alpha is root of this expression. Alpha is 0 of this expression. So 1 minus cos 0 gives 0 again. So this will become 0 by 0 form. So apply L'Hospital rule, and it will become 2ax plus b into minus cos becomes sine of this whole thing, and the denominator becomes 2 into x minus alpha, and this is again 0 by 0 form. So differentiate numerator and denominator separately once again. It will give you, when differentiating, while you differentiate, you're applying d dx of u and v, this formula. Okay, so this will become this expression, you can see. Now to find the limit as x tends to alpha, since alpha is the root of this equation, alpha is the 0 of this polynomial, so as x tends to alpha, it will become sine 0. Okay, so sine 0 is again 0. So as x tends to alpha, this will become cos 0, which is again 1. So the limiting value is 2a alpha plus b whole square over 2. Now see, in the options there is no existence of b, so we have to eliminate b from here. So now we are going to put the value of b from this equation. We will get b is equal to minus a into alpha plus beta. So put b is equal to minus a into alpha plus beta. This will give you a squared over 2 alpha minus beta whole square. So option 4 is correct. Option 4 says a squared over 2 alpha minus beta whole square. Let's go to the next question. Next question says fx is a given function where fx is equal to 1 over x to the power 1/3. Okay, now there are 4 options. This function is not continuous, not differentiable. It is a function of bounded variation on every finite interval in R, and it is not a bounded variation on every finite interval in R. Okay, you can easily see that this function is continuous everywhere, including the point x is equal to 0. Okay, so first option is discarded. What about the second option? It says fx is not differentiable, but fx is differentiable everywhere except x is equal to 0. So now we have to check either option 3 is correct or option 4 is correct. Now let us consider a finite interval a to b. Okay, let me cancel this. A finite interval a to b, and you can see f is monotone right there. Why f is monotone right there? You can see if x is greater than y, then x to the power 1/3 is simply greater than y to the power 1/3. So that is why f is monotone. Okay, and monotone functions are function of bounded variation in every finite interval. So option 3 is correct, and this simply implies that option 4 is incorrect. Now let's go to the next question. I will intentionally leave this question because this question says Which of the following series is not uniformly convergent on this interval, closed 0 to 1? But these these two options, option 2 and 4, both are not uniformly convergent in this interval. So I think there is some problem in this question because there are more than one options are correct. Okay, so let's jump to the next question. The next question says that in the extended real line, every sequence has a convergent subsequence, is convergent, is monotone, or is unbounded. Now, the simplest approach to solve this question is discarding options. Okay? To discard option 2, you will take xn is equal to minus 1 whole to the power n. Okay. This sequence is not convergent. So simply option 2 gets discarded. Take this sequence again. It is not even monotone. So this option gets discarded too. And the same sequence is not unbounded. The sequence is bounded, right? So option 4 also gets discarded. So within few seconds you can conclude that option 1 is correct. Okay, when you want to prove that an option is incorrect, to discard that you have to take one counterexample. But when you have to prove that some option is correct, then you have to show the proof. Okay. But to disprove that, one counterexample is sufficient. So option 1 is the correct answer. Now let's go to the next question. Question number 38. Now this seems a big question, but this is not actually a hard question. Okay. It says FA belongs to CAB. CAB means the set of all continuous functions defined on closed interval a to b. And Mx is the infimum of Ft where t belongs to a to x. And capital Mx is supremum of Ft where t belongs to a to x, where x is lying somewhere between a to b. Then M is a capital M and small m are continuous function or not continuous function on the set a to b, closed a to b. Okay. Now let us take some p, any point p in the closed interval a to b. Now find limit x tends to p for small mx. It will become what? Infimum of Ft, t belongs to closed a to open p. Why? As this for small mx, as this x tends to p, this will go to closed x, closed a to open p. Okay, so mx will tend to infimum of those Ft, infimum of Ft for t belongs to a to open p. Okay. And since we know that f is continuous, so infimum for this region and infimum for this region will be same, since f is continuous on AB. This is happening only because f is continuous on AB. Okay, so infimum in these two regions are same, since P is a limit point of this set. Okay. So now we can say that small mx is obviously a continuous function. And by similar approach we can show that supremum of this set is equal to supremum of this set. So mx is also, capital Mx is also a continuous function. So they both belongs to C closed AB. So option 4 is correct. Here our key point is f is continuous, So these two sets are equal. Okay, these two sets are equal. This is our key point.